Hi, I'm Ms. Cho, and in this video we'll learn how to sketch a graph of a polynomial based on a verbal description. Usually they'll tell you some intervals and tell you what's happening in between them, like, oh, it's positive or it's negative, it's increasing or decreasing. Let's review what kinds of intervals we can have. Our first category of intervals is positive versus negative. Positive intervals are the parts of the graph that are above the x-axis. So like here, and it doesn't matter which direction we're going, we just want to know where is it positive or above the x-axis. Negative intervals are then parts of the graph below the x-axis. And the parts of the graph that cross or touch the x-axis are called our intercepts. Our second kind of interval are increasing versus decreasing intervals. Increasing intervals are the parts of the graph that go up. It doesn't matter whether it's above or below the x-axis, what matters is the direction, up. Decreasing intervals are the parts of the graph that go down. So again, we're only interested in the direction here, whether it's going up or down. So these points where it turns around, where it changes from increasing to decreasing or decreasing to increasing, these are called our turning points. Let's take a look at how we can use this information to sketch a graph when they give us the intervals. In this example, we're given 4 descriptions of intervals and we're asked to use the information to sketch a graph of the function. To draw this graph, we're going to follow a 4-step process. The first is going to be to identify your x-intercepts. What are x-intercepts? They're the parts of the graph that touch or cross the x-axis. So one way to find them is by looking for changes in signs. So part of the graph is positive, part of the graph is negative. This is a clue that these points could be intercepts. So I'm going to highlight all my numbers here, negative 1.5, 2, and 5. I'm going to write them all down and then I'm going to plot them on the graph as well. Then I want to remind myself where the graph is positive and negative by going back through the information. So from negative infinity to negative 1.5, my graph is positive. And it's also positive between 2 and 5, so I'm going to draw plus marks right there. And then it's negative between negative 1.5 and 2. So I'm going to draw negative here. My second step is to identify my turning points. Since my turning points are where my graph changes direction, I'm going to look for where it's increasing and decreasing, those points where it changes. So I'm going to highlight my numbers 0 and 3 and write them down. Now I want to know if my turning points are going to be positive or negative. So I look at 0, my y value is going to be negative, and at 3, which is between 2 and 5, it's going to be positive. So now I can plot a negative turning point at 0 and a positive turning point at x equals 3. I don't know what the y values are going to be. These are just guesses, but I know that this is what the general shape will be. My third step is to find the end behavior. To do this, I'm going to look for my infinities. I see an infinity here, 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 and here. When my x is at negative infinity, my graph is positive, so my y is going towards positive infinity. When my graph is at positive infinity, my graph is negative. So this tells me as x approaches infinity, y approaches negative infinity. In other words, as I'm going left, my graph is going up, and then as I'm going right, my graph goes down. From here, all I have to do is connect the dots with a smooth curve. And now you have a sketch of what the graph could look like. Let's summarize. When we're given a description of the polynomial and we're asked to sketch it, we want to do 4 things. The first is to identify or estimate the x-intercepts. Where does my function touch or cross the x-axis or change signs? The second is to estimate turning points. This is where my function changes direction, going from increasing to decreasing, up or down to up. The third step is to predict end behavior. You want to know what's happening at the right when x is approaching infinity, or on the left when x is approaching negative infinity. Finally, once you have all your points and you can connect the dots with a smooth curve, and you can ask yourself, does my graph match all the criteria above?